Woohoo! It's finally time to learn our very first data structure, and one that most likely you're very familiar with. Arrays. Arrays, which are sometimes called lists, organizes items sequentially. That means one after another in memory, kind of like we have here. We have some sort of data at index 0, let's say juice, and then right after at index 1, we have something else, maybe apple. Maybe this is a grocery list. In our computer's memory, it'll be one after another. Because remember, our RAM is a lot bigger than just 7 slots. And arrays are probably the simplest and most widely used data structures. And luckily for us, we're starting with this because arrays have the least amount of rules. And because they're stored in contiguous memory, that is, in order, they also have the smallest footprint of any data structure. So if all you need is to store some data and iterate over it, that is, go one by one, step by step, arrays are the best choice. Especially if you know the indices, that is, here on the left, of the items you're storing. And just as a quick glance, and we'll go over this in more detail in later videos, but lookup or access with arrays are constant time of 1. It's super fast. Other actions or methods that we're going to go over, such as push, are also fast, but then inserts and deletes are O of n, or linear time. But in order to demonstrate arrays, let's actually use code to show you an example. We have our little playground over here. And again, you can use whichever language you prefer. I'm just going to demonstrate this in JavaScript. We can create a simple array. Let's call it strings. And this array, again, using the square bracket notation, will have A, then B, then C, and D. And we've just created an array in JavaScript. Now, looking at this, and based on what we've learned so far, we can make a couple of assumptions. For example, to store the letter A, letter B, letter C, letter D, that's 1, 2, 3, 4 items. If we were on a 32-bit system, that is, we have 1, 2, 3, 4 shelves to store the letter A in zeros and ones. Well, if that's the case, we just multiply 4 times 4. So 4 items, and each item taking up 4 shelves in our memory. That means we're using up 20 or 16 bytes of storage. If we remember, in our little example here, that with a 32-bit system, we have 1, 2, 3, 4 shelves to store this number. Again, this is a bit of a simplified version of looking at it, but I hope you see what we're doing here. We're simply storing A, B, C, D in sequential order in our RAM, our random access memory. So the computer now knows where to find these items. Therefore, when I do strings 2, I'm telling the computer, hey, go to the array called strings. You should know where that is because underneath the hood, you stored it for me. And grab the third item. Remember, the indexes are 0, 1, 2. So grab the third item from where the array is stored on your memory. And if I run this, I'll get C. The computer is going to grab that information for me because here it stored it for me and here it's grabbing it for me. All right, so let's do a few more operations with arrays and see what the pros and cons are. Well, in JavaScript, we have a few methods that we can use with arrays. One is push, which simply allows us to add something at the end of the array. So strings dot push E. And if we just remove this, and let's have a console.log of strings. If I run this, I get A, B, C, D, E. This string push operation, because it just adds it at the end of the array, is an O1 operation. All we're doing is adding whatever item we want at the end. We're not looping through anything. So hopefully that makes sense why that would be O1. That's very convenient. What's another method that we get? We can also use pop. And pop is the opposite of push. Pop will simply mean to remove the last item from the strings, from the array. If I click run here, you see that the E was moved. If I do strings.pop again and hit run, we see that this time around we've added E, then we removed E, and then finally D to be left with A, B, and C. What do you think the time complexity of this operation is? Once again, it's O of 1 because we're not looping through anything. We're just removing the last item. And remember, our computer knows where last item is stored. We're simply saying, go to index of, let's say, 7, the very last item, and remove the bread. Well, let's do something interesting here now. What if we want to add an item at the beginning of the array? Maybe in here, we want to add the letter X. Well, we have something called onShift in JavaScript. And depending on your language, you'll have perhaps something different. But the idea here is we simply do strings.onShift. And by the way, you see here how REPL.it actually gives you the parameters that you can enter. In this case, it just says what items, which is a string, should I enter. In our case, I'll say I want to unshift X, which is saying just add X at the beginning of the array. If I click run here, we see that X has been added at the beginning of our array. What do you think the time complexity of this operation is? And by the way, as we go through data structures, and because we know big O notation, isn't it pretty cool that we're able to think about code beyond just, oh, I'm just doing this. We can think deeply about what's happening underneath the hood. Why might this operation be longer than this operation? I find that fascinating. And when I first understood this point, it really made me a better engineer. And I hope you're starting to get this aha moment for you as well, especially if this is your first time with data structures. Now, on shift, what are we doing here? Well, remember, strings are essentially stored. If I move this to a new line, the computer knows that this is at 0. This is at index of 1. This is at index of 2. And this is at index of 3. When I add X with the unshift, I'm all of a sudden adding X into our array, but we now have to shift these numbers because the indexes are still like this. But this time around, we have to say, okay, 0 is now at X, A is now 1, B is now 2, and C is at index 3, and D is at index 4. And just by me doing this, you might have seen something. We just iterated, looped through everything, and reassigned the indexes. And I did 1, 2, 3, 4, 5 moves, or 5 operations to realign the indexes. And this should give you a hint. That is, this operation is O of n. Depending on the size of the array, that's how long it's going to take to do that operation. We're looping. So right away, we know that, with arrays, maybe it's not the best data structure for adding items at the beginning of the array. What if we wanted to add something in the middle of the array? So we can use the method splice here. Let me scroll down a bit. And with splice, I can say strings.splice. And again, I get a hint of what I can do. The first is the start number. So I want to start at index of 2. And remember, we have this array here, X, A, B, C. So we're starting at B. And the second parameter is the delete count. What do we want to delete? Or how many things from this index do we want to delete? In our case, we don't want to delete anything. We just want to add. So I'll say 0, and then the items that we want to add. So let's just add a string that says alien. Oh, and let's remove this X from our original array. That's better. Let's hit run. And there we go. We have X because we've unshifted A, then alien, B, C. So splice told us go to index of 2, 0, 1, 2, where B was initially, and add alien instead of B and just shift things over. So what we've done here is, if we go back to our example, we have the X in our array, and we shifted these indexes of X and A are still the same, but we shifted B over and said, in here, I want you to add alien And we now had to go over everything and say 2 for alien, we want 3 for B, 4 for C, and 5 for D. So what's our big O here? We don't need this comma. Well, our big O in this case, we did half of the operations because we changed half the array. We looped through half the array. So it would be O of n divided by 2. But remember, our rules when it comes to big O, we remove constants and simplify to just O of n. Worst case, it's going to be O of n operation. All right. I'm going to leave this for you so you can play around and try different methods on arrays. But I hope you understand how they work and how there's some good things that we can do, such as accessing the array. That is O of 1 because it's, well, extremely fast. We know exactly where it is in memory. We can push and pop. But when it comes to unshifting or splicing or even deleting, because with splice we can even do deletes, that's going to be O of n. And if we go back to our chart, we should now have a better understanding of why arrays lookups are extremely fast. We know where they are. We know why push, adding at the end of the array, is extremely fast. But why inserting and deleting might not be the best or the fastest when it comes to arrays. But here's the thing. There's actually 2 types of arrays. And in the next video, we're going to talk about these 2 types. I'll see you in that one. Bye-bye. Welcome back. As I mentioned in the previous video, there are actually 2 types of arrays. One is called static, and the other, dynamic arrays. Now, what is the difference between the 2? Well, the one limitation of static arrays is that they're fixed in size, meaning you need to specify the number of elements your array will hold ahead of time. So in this case, if this was a static array, I would say create an array of 7 items, knowing beforehand that in my grocery list, I'm only going to have max 7 items. Because arrays are allocated in adjacent blocks of memory when they're created, there's no guarantee that after we've allocated 7 shelves of memory that you can keep adding things on, especially in order. We solve this problem with static arrays that require us to say ahead of time, hey, I only want 7 shelves of memory, with dynamic arrays. And dynamic arrays allow us to copy and rebuild an array at a new location, which with more memory if we wanted more memory. So for example, with our static array, if we realize that we forgot another item on our list and we need 8 items, what happens is we copy this entire array, we allocate 14 blocks of memory, and paste this list plus the 8th item into that new location. Let me show you how this works with code. You see, in languages like C++, let me scroll down over here. In C++, which has static arrays, to create an array, you would do something like this. You would say int a 20. And this says, I want an array that has space of 20 items. Or you can do something like int b5, and then fill up the array of 5 items with 1, 2, 3, 4, 5 integers. That's what int stands for, numbers. And because of this, and because this is a static array, in order for us to add a 6th item on here, well, we would need to copy this entire array and move it over to a completely different area of memory in order to create the space for it. Now, luckily for us, when I showed you with JavaScript how to do this, well, we never had to worry about it, did we? In our JavaScript example, we never really allocated memory. And that's because in JavaScript and other languages like Python, where you have lists and ArrayList in Java, they work like dynamic arrays. They automatically allocate memory according to the increase in size of the array. So right off the bat, you're thinking, dynamic arrays are way better, easier. I don't have to think about memory because of automatic resizing. And that gets into a discussion of managing memory, which low-level languages like C++ allow, while higher-level languages like JavaScript allow us to not think about memory and let the machine take care of it for you. There's times where maybe you do want to manage your memory and times where you don't need to, based on your needs. Obviously, having more control over memory allows you to really tweak things and make things faster. And that's why languages like C++ can be much faster than higher level languages like JavaScript. But we don't need to get into that. What we want to get out of this lesson is that dynamic array expands as you add more elements. So you don't need to determine the size ahead of time. But you may have noticed something with dynamic arrays. You see over here how I have append at O of 1. That is the same as the push command that we did in the previous lesson. But I have a star here that says it can be O of n. Why is that? Well, if we remember our array, and let's remove the extra items here that we don't need. So just say A, B, C, D. If underneath the hood, JavaScript and our machine only created 4 blocks of memory for this array, and we add another letter underneath the hood, because this is a dynamic array, it's going to loop over these items, copy them, and move it to a different location with now 8 blocks of space, so that we can keep adding onto here. And you see here, because we did this looping, the operation becomes O of n. So that's something to keep in mind. Although it's a minor detail, it's good to know how things work underneath the hood. And most of the time, with the languages that you're working and during interviews, you will be talking about dynamic arrays, and you won't have to worry about allocating memory and thinking about the possibility that you might have to copy the array. That's really low level. But I wanted to show you how they work so that you have those fundamentals going forward and understand that when it comes to arrays, just because you're adding at the end using the push command, you can't assume that it's O of 1 most of the times or constant time. But every once in a while, you might encounter a situation where it's O of n, linear time. I'll see you in the next video. Bye-bye. Now that we know how to use arrays, where they're fast, where they're slow, we're going to get into a part that is not crucial for interviews, but it's good to understand how they work and how to build an array. Most likely in an interview, you won't get asked, hey, build an array from the beginning. But I do want to build those foundations for you so that we understand arrays from a fundamental level. So let's build an array ourselves. Now, in this video, we're going to be using the class syntax in JavaScript. So we're going to create an array class. Even though with JavaScript and many other languages, we can just do this and we've created an array. Let's see if we can build one of our own. Because as you'll find out as we go through this course, data structures are simply things that we can build from scratch. We can create whatever data structure we want. We can create our own data structure. The most common data structures are well known and are already implemented in most languages because they're so useful. But you are able to build any data structure you want from scratch. And as you'll find out, most data structures are built on top of other data structures. Now, to get started, we're going to create an array in JavaScript. But just a heads up, JavaScript is a bit of an interesting case. Arrays in JavaScript are just objects with integer-based keys that act like indexes. And that's what we're going to build. Different languages will have this implementation differently, but what we're going to learn here is still going to be applicable to how arrays work in other languages. So we're going to start off with creating a class. Let's start off with creating a class, and we'll call this myArray. And within the myArray, we'll have a constructor, which is the initial function that will be run when we create this myArray. And this constructor is going to have 2 data points. One is the length property, because with an array, we're able to determine the length of the array. And the initial length will be 0. That is how many items the array has. And then we'll obviously have the data within the array. And this is going to be an object. Now, what's the most common action that we have in an array? Well, it's the access, to access the data. So let's create a get method. And this get method is going to take an index to actually grab the data from memory. So I'm going to just say return this dot data. And if this keyword is confusing to you, make sure you watch the previous video. this .data is just referring to this data that we've created in the constructor. And we're just going to return the data at the index that we are requiring. Let's see how this would work in action. To create a new myArray, all we need to do is say const new array. And we use the new keyword in JavaScript to instantiate this or create a copy of this class, like this. So now if I do console.log new array and I click run, I get my array that has property length of 0 and data that is empty. If I do new array dot get 0, index of 0, I get undefined. Well, because there's nothing in this object. We have no items. And JavaScript automatically has the type undefined when, well, there's nothing. Let's add our next method. That is the push method to add something at the end of the array. So I'm going to create a push method, and this method will take in an item that we will give it. And within here, we'll simply add this to the data of our object. It's going to add it to the length of our item. So because we have 0 items and the length is 0, this is going to add the data at this.data 0 index. And the 0 index will simply now contain the item. And because we want to keep adding items if we wanted to, we will say this.length plus plus. Because now our array has a length of 1 instead of 0. So that next time we run the push method, this.length will be 1, and the new item will be added at index of 1. And let's just return this.length for now, because the typical push method in JavaScript will usually return the length of the array. Let's run this and see what happens. I'm going to say that down here, we'll have new array.push, and we're going to push high. If I run this, I see I have my array, length 1. Data is going to have a property 0 of high. Nice. What if we add another thing? Let's do new array.push, and we'll say u. If I run this, I have length of 2 now with index of 0 at high, or index of 0 has high, and the index of 1 has u. Very cool. What else can we do? Well, let's add the pop command to remove the last item of the array. Once again, we have the pop method that doesn't receive anything. We don't need to pass it a parameter. All we need to do is delete the last item in the array. We can simply have a variable, let's say last item, that grabs the last item in our data object. So this is going to just simply be this.data at index of length minus 1. Remember, we want the index of 1. Even though the length is 2, because we're counting 0, 1, we want the last item in the data. And from here, we can just use the delete keyword in JavaScript and say this.data at this.length minus 1, just delete that item. And obviously, we need to decrease, so just shorthand here in JavaScript to decrease the length of our data by 1. And then finally, we can just return the item that we deleted. So now if I run another command, and by the way, you might see here that I've missed the semicolons in JavaScript. Most of the time, you can get away with not adding semicolons, and some people don't use semicolons at all in JavaScript. Don't get too distracted by that. Sometimes I forget, and it's not really important, at least for our purposes. Let's add a new item to the array. That's going to be the exclamation point. And I'm going to say my or new array.pop. If I run this, I get an error saying item because this should be last item. There you go. Let's run that again. And we see that it's high u because the exclamation mark has been deleted. If I run pop again, I see that I have length of 1 and only high remaining. Very cool. All right, let's add one last one. And to show you why some operations in arrays are O of n, we're going to add the delete method. And the delete method is going to take an index, which item we want to delete. And in here, we will have to do a const item. So we're going to create a reference to this .data index, which is the item we want to delete. And how are we going to delete this? Because remember, in an array, we'll have to delete the item, then shift the index of all the other data types by 1. Well, because we want to follow good coding practices, using the idea of single responsibility principle, let's add another function that does this for us, that does the shifting of data for us. I'm going to create a new method, and we do this in JavaScript using the this syntax, shift items. And this method is going to take the index that we received here in the delete. Now, this shift items, we can create it here and say that shift items method. And by the way, I use the words function and methods interchangeably sometimes. Method simply means it's a function within a class. So this shift items will be a method of my array. But it is a function. So this function, which is a method of my array, will have the index parameter passed into it. And this is where we do some fun things. We're going to have to loop through the items. So that's a for loop, which right away should ring the bell and say, ooh, this is an O of n operation. We're going to have an index of 0, or I of 0. Actually, instead of 0, remember, because we want to shift items, not all of them, just wherever the index starts from, we say index. And now I will have to be this.length. So I is less than this.length minus 1. And we're going to increment I by 1 each time through the loop. Within this loop, all we're going to do is say this.data, our data, at each index that we loop through is going to equal this.data at I plus 1. What just happened here? Well, we're saying start at the index that we want to start the delete from and iterate through it all the way until the end. And within this loop, I want you to take each item in the data that we have, and instead of what it had before, I want you to add the data that is right next to it at plus 1. So if we had an array that is 0 and 2, I'm saying from the index of 0 over here, I want you to now instead make 0 equal to 2. So index of I plus 1. So we're shifting the items to the left by 1. So we have shifted here all the items 1 to the left. And because we did that, the index that we gave it for the delete automatically gets replaced because that I is going to get replaced. Now, there's an issue here, right? Because now the very last item in the array, that is this.data at this.length minus 1, which is the last item in the array, will still exist. We've shifted everything over by 1, but we've never touched the very last item because we stopped when I is less than this.length minus 1. So this is still full. So I'm going to comment this out and just show you what happens if we just leave it like this. I'm going to run the new array.delete, and I'm going to remove the pop commands for now. And in the delete, I'm going to say I want to delete the U item. So that's index of 1. If I run this, I get hi, U is deleted, but then I have exclamation mark at index of 1, so the shifting is working. But at index of 2, I still have the exclamation mark because, well, we never deleted it. We've shifted everything once over, but we never touched index of 2. So all we need to do to get rid of that is the delete keyword to delete the last item, and obviously to decrement our length. Because we've just deleted an item, we can do this.length minus minus. if we run this now, hey, look at that. Length of 2, high, exclamation mark. Let's play a little around to make sure everything is working here. If, let's say, I add a couple more push commands here, and we'll say here R, hi, you, R, and then let's say nice. If I run this, I get hi, exclamation mark, R, nice. That doesn't make sense. Let's change this to 0 to remove the hi. If I run this, I get you, exclamation mark, R, nice. That still doesn't make sense. Let's remove the exclamation mark so that we only have you are nice. I'm going to run the new array, and we can delete index of 1, which is the exclamation mark, and let's see what we get then. If I run this, I get you are nice. Awesome. Now, you might look at this and want to add your own methods. You might want to, let's say, in here, return the last item just as a reference, which is how it works in JavaScript. But I think for now, you have an understanding of how arrays work and how they're implemented underneath the hood. We have simple O of 1 commands, which are really, really nice. But as soon as we have to start shifting indexes and changing things around, we have to loop over things, which makes it O of n, or linear time. I'm going to leave this for you as a playground after this lesson, so you can add your own things, maybe write it in different languages, and explore a little bit more into arrays. But this video is already getting long. I don't want you to get too bored now, so I'll see you in the next video. Bye-bye. Welcome back. I wanted to add a quick video to let you know about a common interview trick. We're going to be doing some array questions after this, but in interviews, you should treat any string questions, like over here, as an array question. You see, strings are simply an array of characters. Most of the time in an interview, when you get a question like reverse a string, what you should be thinking is to convert this into an array, do some sort of a loop on it or an operation using something like a split method in JavaScript, and then returning it as a string after you've finished the operations with them. So that is a very common interview question where you're manipulating strings. Just keep that in mind, and we'll actually demonstrate this in the next video when we do a very common interview question. I'll see you in that one. Bye-bye. Welcome back. Let's get into some fun interview questions. We're going to start off with a very, very common one, and it shouldn't be too complicated to start us off. The interviewer asks you, can you create a function that reverses a string? So if you passed into this function right here, hi, my name is Andre, it should return this gibberish that is, oh, and I forgot M here, this gibberish that is, well, backwards. It's just simply reversing a string. Now, I want you to go ahead and try this in your own REPL.it or whichever text editor you use and see if you can think through the problem, use what you know about arrays to solve this. Now, keep in mind, when it comes to questions like these, there are many ways to do things. As programmers, we know this, right? There are so many ways to solve a problem. And depending on our style, our knowledge, and time, we're going to come up with different solutions. So if your answer is different than mine, well, that's not the worst thing. What you want to be able to do is to think through a problem and understand why you made those decisions. So go ahead, reverse a string, and I'll see you in the solution video. Bye-bye. Welcome back. Now, I'm not going to go over all of our steps that we used in the section where we talked about how to solve problems and how to talk through your problems in front of an interviewer. And we even watched that Google video of all the things you need to do. Because that's going to take way too long of a time, I'm going to speed things up and just talk about the key points of how you would solve this problem. Well, in order to reverse a string, the first thing we want to do is some sort of a check of our input. We can't just assume that we're going to always receive a string. What if somebody calls the reverse function with, well, undefined, or with a number? What happens then? And a good thing to always start off with is to check the input. In my case, I'm going to do a simple check. Let's say that if there's no string, so that is undefined, or perhaps that the string.length is less than 2, that means, well, if string.length is less than 2, that means I'm just receiving one letter or no letters, in which case we don't really need to do any operations. It's already kind of reversed. And we can add different input validation here, such as using the type of keyword in JavaScript to check if it's a string type. But that's something you can just do on your own. Actually, let's implement it since we're here anyway, just to show you. So I can say type of string if it doesn't equal string. Type of str, which is the parameter we receive, doesn't equal the string type. Well, in that case, we can just return, that's not good. Otherwise, let's do some operation. To reverse the string, well, let's think about this. We want to convert it into an array. So I'm going to create a backwards array. And this is what we're going to return from the function. I'm going to return the array that is reversed, but we want to return a string, right? It reverses a string. This should return a string. Even though we're going to convert whatever we receive into an array, at the end, we want to turn it back into a string. So in JavaScript, we can do the toString method or the join method. And we just say join all the items in the array. Now in here, we're going to grab the length of the array or the string because we're going to be using it a lot and we don't want to have repeated code. So I'm going to say length minus 1 is how many items we have in the string, or maybe we should name this items number. Or actually, total items. That's a better name. Now, these total items, so we're going to loop through our string. We'll say let I equals to the total items. So I is going to equal however many characters we have in our string. And we're going to keep going until I is equals to 0. And all we're going to do, because we want to go from back to front, we're going to decrement this. So we're going to go from the length of the string all the way back. So we're going to start off with I, E, R, D, and A, and insert those into an array that we've created, the backwards array, one by one. So in this loop, all we're going to do is say backwards dot push each item that we're going to create. So str I. And I know what you're thinking. Whoa. Why didn't we just convert the string into an array? You told me all about converting strings into an array, and we didn't really do that. And JavaScript actually has the str.split, or we can run the split command to split things into an array. But with JavaScript, we can actually just use strings as arrays and access each property like this with bracket notation so that they essentially are arrays. So we don't have to run any split commands. This also works. And all we're doing is we're going backwards one by one and pushing each item of our given string into our array. So if I console log here before we run the join command, the backwards array, and I run reverse, and let's reverse the string. Let's run this. Oh, and you may have noticed that this length didn't really come from anywhere. It should be total items. So this is the total items. This is the problem with live coding. I try to show that everybody makes mistakes, even myself. And it's good because this way you think through the problem. And these total items, remember, we want to keep going as long as I is greater than or equal to 0. So if I now run this, hey, look at that. We have an array with all of our backwards items right in here. And you see here that the return value that we get is the backwards string that we received because we join it at the end. Very cool. I hope you got that answer. Or maybe you have a better answer than me. Because what I did here is not necessarily the cleanest way. And depending on which programming language you use, you might have built-in methods that simplify this step. Let me show you what I mean. In JavaScript, for example, we can use some built-in methods that come with arrays to just simplify this whole thing and make our code a lot more readable. Let's create a new function, and I'm going to call this reverse2. And this reverse2 is going to, once again, receive some sort of an input. I won't do any input validation for this one. You can just assume that we can just copy and paste it here. But in here, we can do a simple return statement, grab the string, run the split command, because this time around, we're not going to access the I like we did up here. We're going to convert it into an array so that we can use a built-in method that comes in JavaScript arrays called reverse. And this reverse does what we just did here for us. And now we just join it at the end. So by using a built-in method called reverse, I avoided all this work. How nice is that? Let's see if that works. I'm going to say reverse2, I'm going to run, and look at that. It's still working. What about another solution? Again, many different ways. And let's say the interviewer says, is there a more modern, cleaner way that you can make this function? And because in JavaScript, there's the new ES6 syntax, you can even create a one-line function, call it reverse3. That's going to take a string, and it's going to do string.split. And again, do the exact same thing using arrow function this time around. And this should still work the exact same. Look at that. And if you want to get fancy, you can again use a new feature of JavaScript, which is destructuring, or not destructuring, this is the spread operator. If I run this, we no longer need the split. I can run this and I get the same thing. Again, I just want to demonstrate to you that there are many different ways to solve a problem. And an interviewer is not going to reject you for a job just because you implemented it this way versus this way. It depends on how you deliver your solution. And this is something that we talked about in our How to Solve Problems section. How you want to talk through the problem, explain to the interviewer why you did. And as long as you understand the pros and cons of each solution, that's what makes a great engineer. I'll see you in the next one. Bye-bye. Welcome back. It's time to do another fun array interview question. An interviewer asks you, given two arrays that are sorted, can you merge these two arrays into one big one that's still sorted? So if I have a function called merge sorted arrays, and I give it two parameters with two sorted arrays, can you make it so that it returns 0, 3, 4, 4, 6, 30, 31, as you can see, completely sorted? Let's see what you can come up with, and I'll see you in the solution video. Bye-bye. Welcome back. It's time to sort some arrays. Let's grab this function, put it at the very end, because hopefully it will work at the very end, and start writing our code. We'll start off by first defining the function called merge sorted arrays. It's going to take the first parameter, which is the first array, then the second parameter, which is the second array. I'm going to first define some variables that we're going to use throughout the function. The first one will be a constant, which is merged array, which will be our answer. For now, it's going to be an empty array. And we might as well just make sure that we return this merged array at the end. Hopefully it all works and we can populate this with these two arrays. Now in here, I want to grab the array1 item just for reference, and this is going to be our very first array item. So this simply has the 0 item here in our first array. And then we'll do the same thing, array2 item, which is going to grab the number 4 from here. Now, the very first thing I like doing in a function is checking for some sort of an input, making sure that everything works. I'm going to spare you the time of me doing this because you should have an idea of how to check whether it's an array, whether you have two parameters. But the one input that I think is worth checking is what if we have something like this, where the second array is just an empty array. In our case, we can just return the first array because, well, it's already sorted. We're still merging the two arrays, but the other array doesn't have anything. And that's the same if this first array was just empty as well. So to avoid any extra work, let's check for those conditions so that right away we can give out the answer and make our function more efficient in those cases. So I can just do an if statement. I'll say array want length. If that is equals to 0. So if first array is empty, just simply return the second array. And we can do the same for the other case. If array 2 length is empty, then we can just return the first array. Nice and simple. But now let's get into the harder topic, which is what happens if both of these arrays are full, like they are now. Well, just to change things up, because I've been using the for loops for a while, I'll use the while loop in JavaScript. And this simply says loop through the items while a condition is met. In our case, I'm going to say while there is an array 1 item, or there is an array 2 item, do something. And remember, these variables are simply, for now, the first item in each one of the arrays. And by the way, if you're wondering why sometimes I use const, sometimes I use let, well, const means that once I assign this variable to this array, I can't modify it. I can't say merged array equals to 2. It's going to give me a warning because it's a constant. I can add things to the array, but I can't change this reference to the array. On the other hand, let allows me to do that. So later on, I can say array 1 item equals to something new, like array 1 in the index of 1. So that is why we're using this syntax. It's a new ES6 syntax in JavaScript. All right. So while we have things in the arrays, we want to first do a bit of a check. Let's say if array 1 item is less than array 2 item, that is, if 0 is less than 4, we want to add to the merged array, empty array, we want to say push, and we'll push the first item in the array. So we're going to push 0. And because we've now pushed the 0 item into this array, we don't really need to worry about 0 anymore. So we can just simply say array 1 item is now going to equal array 1 at index of 1. Right? Because now we want to move to array item that's over here at index of 1, which is 3, so that we can compare 3 with 4. Now we want to increment this every time. And because we are doing a loop here, let's convert this into an index that is I and increment it I++. And at the top over here, we can just say for the beginning that I is going to equal 1. So that way, as we loop through this, this is going to increment with I++, so that is increment by 1, so that we can go 0, 3, 4, 31. And by the way, I just noticed that I can't spell. This should be array over here. All right. Now that's the case when array 1 item is less than array 2. But let's do the other side. If array 2 item is less than array 1, we now merge into the array 2 item. Because if array 1 item is not less than array 2 item, we don't even need to add a condition here. We know that array 1 item is greater than array 2 items, in which case we can just add the second item. So that is, we add this item instead. And again, we want to do the exact same thing that we did with the first item, or the first array. That is, the array 2 item is now going to equal array 2, and we need a different index of this. We can't use the same one, right? So we can just say this is going to be j, and up here, we simply do the same thing. J is going to equal to 1. So once we figured out the 0 index items, we can then move on to index of 1, then index of 2, index of 3, so on and so forth. Now let's check this code and see if it works. If I run this, you'll see that my browser just crashed. And that's because I have a setting on REPL.IT which allows for this to happen. Most likely, if you're using the default settings here, it will give you a warning. But let's go back. Why did that happen? This is why it's always a good idea to go step by step and make sure things work. We did a lot of coding here without actually testing if any of this works. So a good note here is to pause every once in a while and just test your assumptions, log out the answers. In this case, we missed a critical point. That is in this check over here. If we do the while loop as long as array 1 item or array 2 items are populated. And we check here if array 1 item is less than array 2 item. But the problem here is that we could have a case where one of these, because we're using OR, could be undefined or we reach the end of the line. In order to account for that, the critical thing to do here is to always know how your code is running. So let's do a console.log here. Say array 1 item, and then array 2 item. Let's see what we get throughout the loop. If I run this, it's going to crash again and we won't be able to see our logs. So I'm just going to write down the correct version here and then explain why we did what we did. I'm going to just say if array 2 item, if the array 2 item doesn't exist, so if we have undefined, it's going to turn this into true, so we run through this. What is that? Let's have a look. Notice what we just logged here. We've logged array 1 item, then array 2 item. So this is what we're comparing throughout our loops. 0 and 4, then 3 and 4, then 4 and 4, then 4 and 6, then 31 and 6, 31 and 30, and then 31 and undefined. You see here how the second array item becomes undefined. And in order for us to bypass this undefined, which becomes undefined here, and we use the exclamation mark in JavaScript to turn this into a true statement. So it turns into this so that we can add the 31 in array 1 into the final slot of the array. Now, if this was like this and I run, we get undefined for the first array. However, because we're doing this second check, which is array 1 item less than array 2 item? And in our case, if we do undefined less than 6, which is what we're doing here in this comparison, if I run this, and let's console.log this, see what the answer is, I get false. So even though in this time around, array 1 is undefined because we've gone through it, because this statement is false, we go to the else statement and fill the rest of the array with 6 and 13 or 30, which come from array 2. Now, I wanted to point this out to you because this may not be the cleanest solution, right? I mean, looking at this code, just think about what I had to explain and draw out for you to fully understand how this works. And I did this for a specific reason. During the interview, if you have to explain things in detail like this and write things out, well, perhaps there's a better way of writing it. Because an interviewer is going to get confused as to what this means, then what this means, and it doesn't really read like English, does it? Ideally, these functions are really, really nice to just read. So perhaps I can take this part of the function and convert it into its own function and just name this as should push first array item. And this should be should push array 2 item. And by extracting out these pieces of code into their own little function, you can clean out this answer and make it more readable. And interviewers are going to like that. Now, during an interview, you may not have time to do so, but you can let the interviewer know how you wrote the solution and you understand that this is probably not the most readable solution. And this is what you would do to clean it up. You don't have to actually code it. As long as you tell them and you understand where you would improve things, that in an interviewer's eyes is just as good as you actually coding it that way. All right, looks like this is working. If I do an empty array here, I see that it's still working. Our answer is looking good. Hope you got this far. I'll see you in the next video. Bye-bye. It's time to celebrate because you just finished your first data structure, and they're going to get more and more fun. But you see here that we've started to complete our mental model of data structures. I promised you that by the end of this course, this whole diagram is going to make sense. And we've finished a small part of it. The arrays. We talked about static and dynamic arrays. We talked about the big O complexity and how dynamic arrays can sometimes have O of n appends. Because, well, sometimes we have to double up or expand our memory. We also talked about how strings and questions regarding strings can be treated very similar to array questions, where you just convert them to an array and then join them back up and return a string answer that you need. And there's a few other points for arrays that we're going to talk about when we get into algorithms. But by now, you should take a look at the Big O cheat sheet and understand why the array data structure has these Big O numbers, and understand when an array is a good thing to use. One thing that you'll note when it comes to arrays, especially when we get to algorithms, is that they're really, really good at having sorted data. When it comes to sorting, arrays are awesome because they're in memory in sequential order, according to their index. Now, before I go on to the slide, you can pause the video, think about when you would want to use an array, when you wouldn't. Because in about 5 seconds, I'm going to show you the pros and cons. So pause the video and the answer to when you should use an array. Well, here it is. Arrays are great for fast lookups. That is just accessing information where you know which index you want to look up. It's really fast at push and pop. So adding things at the end of an array or taking things out at the end of the array. And of course, because it's ordered. Having something that is ordered and close to each other in memory makes it really fast. However, it has slow inserts and deletes because we have to shift arrays whenever it's not at the very end of the array. And then finally, if using static arrays, it's fixed size. That means sometimes you have to declare the memory ahead of time and how large of an array you want. But that can be avoided if we use some of the more modern languages that have dynamic arrays. Also, I just realized that this smiley face kind of looks like a crazy person, but this is meant to be good. This is good. This scary little icon, that's bad. Okay, I think we get it now. We're going to come back to arrays because a lot of other data structures we're going to talk about later on, like queues and stacks, are related to arrays. But for now, I want to get into other data structures because we still have a few to go through. I'll see you in the next one. Bye-bye.